Next, we're going to generate a style sheet so that we can have nice syntax highlighting. And you can do this from the command line with pigments. So you need to tell it which style you'd like to generate a style sheet for. In this case, we're going to use the pasty style. And you need to tell it which formatter we're going to use. In this case, it's going to be LaTeX. If you were generating HTML, you could generate a CSS file by passing HTML here. And in fact, we'll just go ahead and run this. This is going to generate CSS codes that you can use just like any other CSS. But in this case, we would like to use LaTeX, and we're going to save this as pasty.sty. We're next going to edit our header file so that it references this pasty.sty file. And basically the way we do this is just indicate we add a use package line, and we just need to have the relative path from the artifacts directory to the location of the file that we just generated. So the artifacts directory is a subdirectory of where we are now, so we just need to come up to the parent directory and reference this pasty file. We're now going to create the first of our example business cards. We have created a file called 001.c, which contains some C source code, and our LaTeX file is now called card001.tex. So we can briefly look at the C source code, and we see that it's just a very short hello world file. Now the next thing we'd like to do is to look at the .dexy file and see how that's changed. So we have our card001.tex, and we've added another filter, which is the Jinja filter, which is going to actually let us incorporate dynamic content. And after the Jinja filter, we still have the header and footer and LaTeX file as before. Now before I mentioned that we could either list our header and footer files as inputs explicitly, or we could use the all inputs option. And now that we have a few other inputs that we need to mention, we're going to just use the all inputs is true as you see here. And as I mentioned, the header and footer files do need to be listed somewhere, so if they aren't listed explicitly as inputs, then we need to list them somewhere else so that they can be there to be picked up by the all input statement. So in this case, we're just going to use a wildcard to say anything that starts with an underscore and ends with the extension TEX should be put through the Dexy filter. And this will mean that our header and footer files are available later. Next, we have the 001.c file that we saw a moment ago, and we're going to run this through a filter whose alias is C, and this is going to compile and run the C code, and it's going to return whatever gets written to standard out by the C code. So that's going to show us the hello world when we come to run this. And then we'd like also to be able to see the source code in this C file, and we'd like to apply syntax highlighting. So the way we do that is we're going to use the PYG filter. The PYG filter by default will output HTML formatting codes. In this case though, we want LaTeX formatting codes. So to do that, we're going to follow the pigments filter with a filter that just has an alias of L. So simply the letter L. And this filter will just force the pigments filter to output LaTeX rather than HTML. So this means that the codes will be appropriate for use in the LaTeX file. So this is our Dexy file. And let's just see then how we use this to actually write our LaTeX document. So Jinja is the templating system that we're using, and normally in a Jinja file you would use double curly brackets to indicate that you wanted to include some dynamic content. But in the case of LaTeX, this is going to clash with LaTeX's own command system. So by default in Dexy, if you're using a LaTeX file, you're going to use double angle brackets to indicate dynamic content. So in our card, the first thing we're going to do is we're going to show the C source code through the syntax highlighting filter, as we mentioned before. We're then going to show the actual output from running the code by putting that same source code through the C filter that again is going to compile and run the code. So we'll run this by typing Dexy, and this is going to run the C code, apply the syntax highlighted to the C source, and then compile a LaTeX document to include all this. And we can open the cache directory and the card001.tex file. Our name is a little longer because we've added another filter. And here we can see what this looks like. So we've got our source code, And then we have the words Dexy says that we included in our document, and then here's the output. Now let's say we'd like to change the source code slightly and update our card. Well, that's as easy as editing the source code. So let's take away those capitals and let's add an exclamation mark. We can then run Dexy again. And we can open our file again, and we see that it's updated to use the new contents of the file. Now let's add another business card design. This time let's use the R statistical programming language for our example. We've added a file called 002.r, so let's take a look at that. The first two lines of this file call libraries that define functions we're going to use. We then open a PDF graphics device. That means that the graph we draw in a minute is going to be saved to a PDF file with a given name. This line is a specially formatted comment, which allows us to divide our script into different sections. So all the text between this start comment and this end comment, as I've highlighted here, is going to be in a section named Spark that we'll be able to refer to later on. In this line, we call a function named sparkline, which is defined in the Yale Toolkit library. And this function is going to generate a sparkline style graph. And what we're going to graph is just 10 randomly chosen points. The rest of the parameters here just define the style of the graph, its kind of look and feel, and what colors it is. This is the comment that ends our specially formatted section. We're then going to call the embed fonts function, which is defined in the GR devices library. And this is going to embed all the fonts that are used in the PDF file. And this is necessary for the printers to be able to print this graph properly. And then finally, we're going to switch off the graphics device and close the file. Now we've modified our .dexy file, so let's take a look at that next. First of all, instead of hard coding the card001.tex, we've replaced this with a wildcard. And so now, as many files as we'd like to define will all be run the same way. And below, we've added another line, which is going to process the R script we just looked at. Now there's quite a lot of filters here, so let's go through each one in turn. The first filter, FN, is a special filter for file names. And you might recall that the file name of the PDF that we defined in 002.r started with Dexy and 2 dashes. And that's a special format, which is recognized by the file name filter. And when that is actually run, it's not going to be saved to that particular file name, but it's going to be saved to a random file name with the same extension. So the file name filter is going to replace that file name, and it also means that the file name is going to be available when we come to create our document. This next filter is the IDEO filter, and this is the filter that's going to interpret that specially formatted comment and divide our document into sections. So this is going to take the R script and divide it into 3 sections. And the first section is just going to be called section 1, and that'll be everything up to the first comment that defined the start of the name section. We have the named section then, which was named Spark, and then there'll be another section at the end containing all the contents after the end. After we've split the document into sections, we're going to pipe it through a filter that will actually run the R code. So the important thing to remember here is that the R code is going to be evaluated in the R interpreter after the file names have been substituted and after it's been chopped into sections. And this filter is going to run the R code, but it's also going to preserve the sections. And the output of this filter is going to be an R transcript, which means we'll be able to see both the input and the output as if we were typing the code into an R terminal. We're then going to syntax highlight that console. And Pigments, fortunately, has a grammar which will not only allow us to syntax highlight our source code if we wanted to, we can also syntax highlight a console transcript, which is what we're going to do in this case. And again, we're going to use L at the end to indicate that we'd like our syntax highlighting we'd like our syntax highlighting to be in LaTeX format. So what we're doing here is we're sort of combining the steps of syntax highlighting the source code with actually running the file. So if we wanted to, we could do this in 2 steps, as we did with the C code, but in this case, because we can do it in one, we might as well. Now let's take a look at the LaTeX file. So in this case, we have some text that we write, which is just Dexy loves R. We're going to set the font size to be smaller because we need to fit this into the very small area. And now we're going to include just the section named Spark, because for this purpose we don't have much room. We're not really interested in the preamble where we incorporate the libraries, and we're not really interested in the end of the file, which is where we just close the graphics device and embed the fonts. Those aren't really what we'd like to show here. All we really want to do is show the sparkline function itself, and that was what was in that middle section. And then what we'd like to do is include the graphics that we drew. So what we want to do here is just include the sparkline itself. And we're going to do that with the LaTeX include graphics command. And as an argument to that, we don't have the actual file name, but we're going to use Ginger to substitute in the actual file name. And because we use the file name filter, we can just refer to random spark, which is the alias we gave to this file. I'm just going to return to the R script for a moment so you can see how this works. And here's our file name, and we have, starting with Dexy and 2 dashes, which indicates to the file name filter that we should alter this file. And the remainder of the file name, leaving out the extension, is going to be the key. So random spark, and that's how we're able to refer to that there. So now we can go ahead and run Dexy. And let's look and see what the file looks like. So we have our text, Dexy loves R, and we have the section that we're interested in, which just has the sparkline graph, and now we can see the graph itself. If we run this again, we can see that the graph has changed because different random numbers were generated this time.